Good afternoon, everyone. Thanks for joining today's session on Cooling Singapore. My name is Anders Ozaya. I'm the project manager of Cooling Singapore. This is an cross-institutional and multi-facet project that Singapore ETH Center leads. Many of you might have heard about the last week news on Singapore breaking records again on high temperatures. I believe it was highest temperatures since 1983. So that's the year I was born. So that's quite of a record. And as climate change is pressing temperature in cities, we have more extreme events. This is becoming the new normal. At Cooling Singapore, we're working to build tools and develop technologies to address the heat challenge from the urban perspective. Today, we will split the session in two. We have a first part with the two presenters giving us context on Cooling Singapore and urban heat. And then we will have a panel discussion, and we'll be happy to answer your questions. So let me dive in and introduce the two guests. Chew Wen Tung is the Group Director for Research and Development at URA, the Urban Redevelopment Authority. He leads his team to research for solutions to meet Singapore's future planning needs. Wen Tung was also previously Executive Director at EDB, and he holds a master's degree in chemical engineering as well as an executive MBA. Our second panelist, Heiko Ajit, is a computational scientist with expertise in modeling and simulations, and his work is focused on software engineering and distributed systems. He has years of experience in working on performance computing and distributed cloud computing. Heiko holds a PhD in computer science by NTU in 2011, and he joined SEC, or Singapore ETH Center, in 2015. He's been holding several positions in Future Cities Lab and also Cooling Singapore since the project started in 2017. Today, he leads the R&D or the DUCT, or Digital Urban Climate Twin R&D pillar. So with further ado, let me get the stage to Wen Tung so he can introduce us and give us a bit of background on the project and the urban heat issue. Wen Tung.
Good afternoon. My name is Wen Tung. I look after R&D in URA, the Urban Redevelopment Authority. Basically, this is Singapore's planning, land use planning as well as conservation authority. So I think all of us know that Singapore, we are a tropical island. So we already are very hot, even without taking into account climate change and urban heat island effect. So today I will talk a little bit about how we are trying to cope with thermal comfort and heat. Okay, so I will let Heiko talk a bit more about the details of the Digital Urban Climate Twins, which is one of the models we are working together, multi-agency, multi-research institute, multidisciplinary to work on. But before we go into all the technical details, maybe I'll just start with the basics. I'll cover some of the basics today. What do we mean by urban heat and the heat risk that we are facing? Some of the mitigation measures that Singapore government, together with the rest of the agencies, the public sector, and the research institutes are looking at. And then how do we leverage technology, such as the modeling technology that we are we are implementing with the digital urban climate twin, of which is an example, and then some of the things that we can do collectively going forward. So historically, our baseline temperature is about 24 to 32 degrees Celsius. With climate change, this is expected to go up by anywhere from 1.4 to 4.6 degrees Celsius. So based on CCRS, this is the Center for Climate Research Singapore's second national climate change study, we can see temperatures hitting 40 degrees as early as 2045, which is within all our lifetimes. Right? So we can start seeing very uncomfortable temperatures as early as 2045. So on top of the So on top of our baseline temperature and the effects of climate change, we have another effect, which is the urban heat island effect. So basically, the urban heat island effect is when the urbanized areas experience higher temperatures than rural areas. So in the places like our CBD, some of our HDB heartlands, as compared to let's say the central catchment or more rural areas like Lim Chu Kang, the temperature can be as difference can be as range from 0 to 2 degrees in the day and 2 to 4 degrees in the night. So that's an additional temperature difference due to urban heat island effect. So if you look at the Singapore map, Singapore mostly urbanized, but we have some rural areas. But if you add all of it together, we already have a pretty high baseline temperatures as a tropical country. And then you add on the effects of climate change and then add on the effects of UHI. So if, cumulatively, we can experience very uncomfortable thermal temperatures in the day and also in the night. Okay. The good news is to address this challenge, we have to address a few things. So for climate change, we have to look at how to reduce our carbon emissions, not just us, but actually collective action by basically every country internationally. And then for urban heat island, it's a more localized effect, and our strategist is looking at more localized action. And the good thing is many of the actions that we take are actually synergistic to help address both climate change as well as UHI. So some of the measures that we are adopting will help both address our carbon emissions as well as to reduce the urban heat. So I move on to the next part to talk about some of the mitigation measures that we're looking at to address urban heat. So this is a very summary chart to chart out our low carbon and heat resistant future. So we summarize some of the key measures. And as I mentioned earlier, many of the measures that we use to address climate change are also applicable to help us address urban heat. A good example is solar panels. So solar panels will help us change our energy source to a more renewable and green energy source. At the same time, it absorbs the solar irradiation, solar heat. So it helps us address the urban heat island effect. Similarly, our measures to help enhance our biodiversity and ecological systems will provide more greenery and shade, which will also help us address urban heat island effects. So as a country, we have launched the SG Green Plan, and our efforts under to address urban heat, it falls under the resilient future, specifically the part on keeping Singapore cool. So this slide summarizes some of the measures that we have to mitigate urban heat. So we have a range of measures. The first one is basically looking at more planning and design to help us facilitate wind corridors and ensuring shade. So shade is a very good strategy for mitigating heat. Then, of course, we want to reduce our heat absorption from the sun and also reduce the heat emissions from various man-made activities. So this is anthropogenic heat from your vehicles, from your industry, from your homes. And this can be done at different scales, at the national scale, at the local scale, as well as at the building scale. So at the national scales, for example, we can look at how we have wind corridors to bring in wind from the coast further inland into the island. At the local scale, we can look at our urban geometry to ensure that there's sufficient urban ventilation and then reduce heat gain from the solar irradiation. And then at the building level, you can look at measures such as cool pane to reflect heat, or solar panels that we talked about earlier. So it can be done at different scales. Okay, so I will talk about the use of technology to help us mitigate urban heat. So one of the examples I will share, this is using microscale modeling simulations for urban design. The example that we use here is actually for Lentor, which we actually launched recently under our government land sales program. Okay, so this is a Lentor Hills estate. If you look at the three pictures, on the right side, okay, on the right side is the baseline where there's no safeguarding. Then the scenario one is safeguarding not of wind corridors but porosity for the buildings. And option two is with safeguarding of the wind corridors. And then we did some modeling, and we found that with the safeguarding of wind corridors, it actually increases wind speeds for most of the plots in the Lentor Hill estate. So moving on to talking about the digital urban climate twin, basically this is federation of models. So it basically collects multiple models, looking at different parts, looking at land use, looking at the industry emissions, looking at the power sector, looking at traffic, heat from the cars, etc., building sector, etc., integrating it and with the at the meso scale as well as the micro scale. And then giving us the ability to run what-if scenarios. So what if we try certain mitigation strategies individually or collectively? So what's the impact on the urban heat for Singapore? And for this project, I think we are working with both Anders and Heiko, which I think they will talk a bit more about the details of the digital urban climate twin, or DUC as we call it for short. So these are some of the what-if scenarios that we are interested to run. For example, what happens if we introduce new parks and open spaces in the hotspots? Just now, I think you saw some of the maps that we showed. We have urban heat island effects. So with the models, we can see where are the hotspots, and if we introduce parks as well as open spaces, how would that help mitigate the urban heat in those areas? I also talked about what happens if we plan for wind corridors. This is not, Lentor Avenue is at a micro scale, it's at a more neighborhood local level. But imagine we do it at the nation level. So are we able to draw in the coastal winds further inland into the more middle part of Singapore? What if we are able to optimize the energy efficiency of buildings in the estate? And how would that impact the urban heat island effect? And another what-if scenario we're looking at is how do we plan for urban density and urban geometry to minimize the urban heat island effect? So these are some of the questions that we hope that we can try to get a better answer with the digital urban climate twin. Okay, so moving on to the last section, just to sum up. Going forward, I think we'll continue to use modeling tools to help us understand and assess the efficacy of individual measures that we try to implement to manage urban heat. So ranging from parks to solar panels to green corridors, etc. So this will help us understand, and as well as which strategies to pursue, at which areas and at what scale. Then I think we look forward to collaborating with different research partners, both academic as well as industry, to address some of these knowledge gaps, as well as try out new solutions. So we talked about cool panes earlier, so we have been working with cool pane providers to see how they can roll this out across with our HDB estates, our schools, etc., and measure the impact of such mitigation strategies. Yeah. and then hopefully over time build up capabilities as a country, both within the public and private sectors, to help us manage the challenge that I talked about earlier, managing urban heat that has come from our baseline, as well as climate change, and of course the urban heat island effect. So thank you.
All right. Good afternoon, everyone. My name is Heiko, and I'm going to talk about a bit more about this digital urban climate twin that Wentong already mentioned in his talk. In particular, I'm going to talk about this gap between science to policy and how we bridge it with this digital urban climate twin. So I just want to clarify perhaps a couple of things about what we actually mean with a digital urban climate twin. And let me start with the digital urban twin first, because it's one of these buzzwords that gets thrown around a lot. Digital twin here, digital twin there. But what exactly is this actually? And in particular, what is this digital urban climate twin that we're talking about today? Now, let's start with the basics. What is a digital urban twin? And what you see here is an image taken from a drone, and some of you may recognize it. It's actually the Singapore business district. This Lau Pa Sat from the top. It's a very nice image. And I like it in particular because you see a lot of urban elements there. You see the buildings, you see the roads, you see air conditioning on top of the buildings, you see the traffic. And you know, if you probably zoom in, you probably see people walking there as well. All these are parts of the city. So when we talk about an urban twin, what do we mean? Do we mean the geometries? So this is the same scene, but this is taken from Google Earth. Looks actually quite nice. They have a really nice 3D model there. And it looks fairly realistic. I was actually impressed when I saw it the first time, how realistic this Google Earth thing is by now. So is that already a digital urban twin of a city, the geometry, the textures for visualization purposes? What about systems and the system behavior, right? So we have traffic systems, cars moving around. We have the building cooling systems, air conditioning and all that. Vegetation, or the lack of it. Vegetation is actually very important in the context of urban climate for cooling purposes. So in my view, and I guess you ask 10 people about what their definition of a digital urban twin is, I'll give you mine. So yes, we have, of course, the geometry of it, the textures, and for primarily visualization purposes. But we also have the dynamic system behaviors of the various urban elements, whether this be traffic. So for instance, we have agent-based traffic models, air conditioning, building energy models, and then, of course, also the urban climate models, because ultimately what we are looking into is the urban climate. So the point is, once we have a digital twin, which is not just for visualization purposes, we can conduct these what-if analysis. And Wentong spoke earlier about the kind of what-if scenarios that URA, for instance, is interested in exploring. So the good thing is, once you have a digital urban twin, you will be able to conduct these experiments in silico, what would otherwise not be possible in the real world. Right? You can't just make a lot of changes in the real world and see what would happen, because A, it's very expensive, and B, you may actually make things worse. So ideally, we have something that behaves very much like the real city, and then we can use it for experimentation purposes. And that's very much what, to me, a digital urban twin is. Now, more specifically, the digital urban climate twin is a digital urban twin, but with a focus on the climate. So we make sure that in our digital urban twin, we have a lot of all the relevant aspects that play into the urban climate. They need to be somehow reflected in it. So there's a lot of things that affect the urban climate. That's the built environment, the buildings we put there, the pavement, basically lack of vegetation. We have heat that we're adding to the city, the transport system, building energy systems, cooling, all that is adding to the urban heat island effect. So the digital urban climate twin that we're building in the Cooling Singapore project has all these models inside. And then how would you imagine policymakers and planners to use it? Well, the idea is that they would be able to ask what-if questions. They can define scenarios. They can use the digital urban climate twin to run these scenarios, and then learn from the insights and basically make better informed decisions. So think of it as a design decision loop. You start with some base scenario. You make some changes to the parameters. Maybe you're not happy with the outcome, you change something else, maybe you throw a bit of photovoltaics in, see what happens, what if we have larger parks, smaller parks. All this, has some effect on the urban climate, so you can play around with this and figure out what would happen if you do certain things. That's the idea of it. And how does this all work? This picture here is not as nice as Wentong's, but it shows basically the same thing. So we have a number of models in there, energy models, and ultimately what comes out of these anthropogenic heat profiles that feeds into the climate models. We have mesoscale climate models, which means that we simulate the whole city on a relatively rough resolution, but we also have fine-grained, high-resolution models for neighborhood analysis. So it depends really what your analysis is about. And I like to think of this federation of models very much like a toolbox. There's all sorts of tools in there, and they don't have to be hardwired in this way. I just want to point this out, it doesn't have to be that way. It's just a sort of an illustration of the kind of models and how they might be connected to each other, but it doesn't have to be that hard in a hardwired way. So depending on what kind of scenario you're running, the right tools will be taken out of this toolbox, the right models, they will be put together in a meaningful way, and that allows you to evaluate your scenarios. But of course, and this is the issue, you can't expect planners to know how to use a supercomputer, which is required by some of these models, or even put these models together. That actually requires a lot of domain knowledge. And this is this gap that I was alluding to at the very beginning of my talk, between basically from supercomputing to policy. Let me start at the foundation of it. On the infrastructure layer, we have supercomputers, we use cloud computing, we use in-house computing. Depending on what models we have, they have all very specific requirements. Some require supercomputing, others not. They may have different requirements in terms of data. So you need to make sure that all these models run in an environment where they actually work. The next thing is all these have to be interoperable. So the output of one model has to be able to be used as input for another model and so on. So there's a lot of computer sciencey stuff that's going on. Obviously, the end user, the planners, they should never have to bother with these kind of questions. That's just not what they are supposed to deal with. Then on the next level, of course, we have this federation of models, which you have heard before. All the different models, how do they connect to each other, what feeds into what output feeds as input into another model, and so on. So this is the stuff that is really running the what-if scenarios. And this is, the next layer is then the application layer, and this is where it gets interesting for the actual end user, because we make all this technical stuff transparent. So we will develop multiple applications. In fact, I'll show you a video of one of the applications that we're building currently, the Duct Explorer. The idea is this is really a front end, a graphical front end that end users can use without having to worry about all these model setups. Once you have these applications, you can then define your what-if scenarios, you can explore different configurations, and based on that, you can then also develop master plans and roadmaps. And sort of that bridges this gap between all the models in the supercomputing in the infrastructure layer and the layer where the policymakers and the planners are sitting, where they think about different scenarios and basically thinking about strategies how to manage the urban climate in Singapore. And just sort of an indication again, so of course on the Cooling Singapore, we work mostly on the infrastructure layer, the modeling layer, federation of models. We build the application, and this is also then where the end users, such as the planners, would come in and give us feedback about, look, we are interested in these kind of scenarios. This is the kind of thing that we want to do. Of course, we can't tell them to do their job, right? So I mean, we are not the planners. And climate is only one aspect of planning. And the planners, of course, they will use a multitude of tools. And this digital urban climate twin is only one of these tools. So that's basically where there's this intersection at the application level and at the what-if scenario level, and I think this is where we have a very fruitful interaction with the agencies. And sort of this is then how we bridge this gap with this digital urban climate twin. And I'm going to show you this video, which is basically work in progress about Educt Explorer. It's a UI, at the moment it's mostly a UI mockup. We are building this application as we speak. We have plans to have a first demo in August. And so this video has actually been prepared by my colleague Isabel, who is also sitting in the audience, by the way. So if you have some questions about that, you can address her directly. But basically the idea is that we will be able to support all these different what-if scenarios that planners might be interested in with a, I guess, relatively easy to use graphical user interface. And again, at this point, you don't see any of this federation of model things happening there, right? Because the user shouldn't be bothered with it. But as soon as you click start on an analysis, that's basically what gets triggered on the backend. On all the servers on the supercomputer, there will be number crunching happening. And once this is happening, or once this is done, the results will be able to be displayed in the application. And then you can also do side-by-side comparisons. So at the moment, we are still building this app. But as I said, sometime in August, we will actually have the first version of it ready. Thank you very much. And I think now I'm handing back to Ander, who will lead us through the discussion. Thank you.
Hi. So thank you very much, Wentong and Heiko, for giving us this overview and hopefully a bit of background also on the pool or the needs, why we are doing this project, and also what are we building, the techie part that Heiko shared with us. I want to open the questions, the Q&A to the audience. I don't know if there's any questions, any comment. Anyone? Yeah, I see gentleman here. Yeah.
Just curious, to what extent does the road infrastructure actually contribute to the urban heat effect? You know, roads are rather dark. There's a lot of it. It absorbs a lot of heat. So I'm just sort of curious, have you guys done any analysis of that? Or rather, if I extend the question, what contributes most to the urban heat effect, given the analysis you've done so far?
Yes. Yeah, roads obviously are very dark, so that has an effect on the albedo, which is then basically, you know, it's heating up. The biggest effect is basically the built environment. It's basically all the modification to the land, pavements, buildings. During daytime, they heat up, and then during the nighttime, you basically have that infrastructure radiating the heat. So basically, the urban heat island effect is actually most notable during the night times and the evening times, because during daytimes, it basically heats up the built environment, which then radiates the heat back into the urban environment at nighttime. Colleagues of us years ago, they have done some measurements and studies and figured out that in Singapore, the temperature difference between the urban environment, and I think they measured somewhere in Orchard Road, and sort of the rural hinterland can be as much as 7 degrees, which means that in that area, it can be 7 degrees warmer than if you would be somewhere in the forest. And much has to do with the built environment. But then there's of course also the other components like air conditioning. It's supposed to keep the inside cool, which it does, but there's a lot of waste heat that basically gets blown out literally into the air. Other contributors are power plants, potentially industry is one, and traffic as well. Yeah, so all that basically contributes to the heating of the urban environment.
Let's keep it in the front. Hi, Laszlo here. one thing that always interests me, and I know very little about this, you definitely are the experts, is how wind can be used to change temperatures in the cities. Because I'm thinking, especially when you have a lot of high-rise buildings, you can probably plan them in angles and in ways that there's like wind tunnel effects that then cool the city. Very curious to hear what you know about that.
I think we look at it two aspects. I think we showed some of the modeling. So at the local level in a Lento estate, as well as maybe if we're using duct to look at it at a bigger estate. So some of these wind corridors will help to remove some of the ambient heat, by carrying it through convection. But the other thing that we are also interested in is what we call outdoor thermal comfort. So outdoor thermal comfort, there are four main factors. One is your temperature, then your humidity, your wind speed, as well as your mean radiant temperature or your irradiation. So with higher wind speeds, you feel more comfortable, even if the ambient temperature is relatively high. So we also want to ensure that the outdoor environment, when you walk around, you walk for lunch, or you are out and about, it's also comfortable. So we are looking at it from multiple aspects. Yeah, thanks.
Yeah, I guess we look mainly to ventilation and porosity more than changing wind patterns, which, yeah, it's kind of hard to do, no? But yeah. Any more comments or questions on the heat aspect or the technology aspect? I guess, Wenton, on your work on planning, on urban planning, the heat aspect will be relevant, but there will be other aspects also, and how can technologies can add to those aspects? I don't know, usability.
So for planning, we don't just plan for heat. So we plan for multiple purposes. But at the same note, many of the measures that we are looking at actually also have multiple benefits. I'll just give you a simple example. So for example, our move towards electric vehicles will reduce reduce the heat from internal combustion engines because it ejects a lot of heat into the built environment. But the main driver for moving towards EV is not purely for heat. There are many benefits reducing the carbon emissions from our mobility systems. It reduces the noise, it creates a more pleasant environment, and of course reduces the heat. So most of the measures that we looked at will have multiple benefits, as well as multiple planning considerations. So we don't just plan purely for heat. But the good thing is many of the things that we do will come with multiple benefits. Same thing for greenery. I think with COVID, everybody has a much better appreciation of greenery, and more people go out to the parks. So it's not just for making the place more livable, but it also reduces urban heat island effect. Yeah. So at the same time, it does help us in that aspect as well. Yeah.
So, and I guess that connects a bit with what you mentioned earlier, Heiko, on the toolbox concept. How can a digital twin or urban digital twin can be expanded to, I don't know, to address those other issues? I don't know, noise, emissions. Is that a possibility? Or?
Yes. I mentioned earlier digital urban twin, right, which is sort of the more general term. In principle, we're not limited to just climate-related models. We could put in other models as well. And in fact, years ago, there was the idea of a cooler, calmer Singapore project, calmer pointing at noise. We then sort of started focusing more on the heat issue. But yeah, we could in principle work on other issues as well, including noise. In fact, I think A*STAR has actually been working on the noise matter as well. So we're not the only ones who are working on this topic.
Interesting. Any comments or? Yep, I see a hand raised.
Hi, just like to check, has there any consideration on greening buildings, that means vertical greening of buildings? How would that be possible to actually reduce the heat? And what are the studies that has gone into that area? Yeah. Thank you.
For URA, actually, we already have an incentive to help companies green the buildings. So it's called LUSH. So and we are, so basically there is already greenery replacements for different areas. They are for the land that they clear, they have supposed to have a replacement greenery. And some of the buildings actually have more than 100% replacement greenery. So for example, like Oasia Hotel, it's a 600% replacement greenery. So for the land area, they replace six times the greenery. Yeah. So that's done through vertical greenery. So we do have some of those effects that we are looking at. Some of the research we are interested in is actually goes beyond that. For example, you look at the roof space. Now it's a competition between solar panels, rooftop greenery, and cool paints. But what if we can integrate some of this? For example, can we integrate vertical roof greenery with solar panels? Does that help the solar panel become more efficient as the temperature drops because the efficiency of the solar panel goes up? So those are some of the research areas we are also interested to see how we can actually optimize our strategies to achieve multiple outcomes. Yeah.
I can add to that our building engineers are also trying to integrate all these concepts, the solar panels, the green roofs, the change of albedo materials on buildings, and how to model those better to have better simulations and more accurate outputs. Yeah. I see a hand. Oh, yes, there's a couple of hands there.
Hi, Manto from NUS. Questions for the panel. We know that there is a southern waterfront redevelopments. Will the project has any impact on the Cooling Singapore initiatives?
Okay. This talking about the Greater Southern Waterfront. So this is one of the new areas that will be for future development, similar to Paleba Air Base. So I think with the Distributed Urban Climate Twin, it can help us understand how to arrange some of the urban design, the geometry, the layout, the safeguarding of wind corridors, etc., as we develop some of these areas. So I think we are hopeful that some of the modeling tools can help us develop in a more climate-sensitive way, such as safeguarding of the wind corridors.
I saw a hand earlier on the back, yeah.
Hi, good afternoon. My name is Sin. I'm from Hello Tomorrow. I just have a quick question. I'm glad that you guys have such an elaborate system for digital twinning. Out of curiosity, what would then be its ability to sensitively pick up, say, new technologies and new innovations that are coming through where the data might not be as complete, but in simulations, being able to also project what the effects might be, and hence affect adoption thereof?
Okay, maybe I'll take a step at that. I think anybody who does modeling knows that data is crucial. Okay, and even for this Cooling Singapore 2.0, we encountered I think some of the biggest challenges are in the data collection. So I think we have worked with the research team to reach out to many parties within the government as well as in the private sector. To collect good data. I think some of the data, I think Heiko can talk a bit about it. We have to extrapolate based on what we know. Some of the things that, for example, I mentioned about, let's say the switch towards EVs, you can measure it and then you can try to extrapolate the effects. But linked to the modeling, the other way is we are also looking at how we can deploy a sensor network throughout Singapore to collect better data so that the model can be even better calibrated. And when we try some of the pilots and trials for different interventions, for example, like cool paints, we actually also deploy a lot of sensors, not just on the building where we put the cool paint, not just on the rooftops, but also at the nearby buildings, nearby car parks, open spaces, etc., so that we can actually understand the effects of such interventions, not just on the building itself, but on the surrounding areas, and that affects thermal comfort, nearby buildings, etc. And hopefully all of these efforts will help us understand some of this intervention better and help us build better models.
Let me add on to what Bentong just said. So we use all these models, and there's obviously a lot of data that we need. to build these models, to validate, to calibrate. There's one thing that we always need to be acutely aware of, and that is that models are not perfect. They can be useful, and they can produce insights, but they should never be blindly trusted. And there's been lots of discussions about, how accurate are these models, what can you do with them. So, and yes, there's obviously certain areas where there's lack of data or where we have very little data. The good thing is we are also trying to explicitly quantify the uncertainty that we get at different stages within this digital urban climate twin. And it helps us actually, or it will help us to identify areas where perhaps we need more data. So instead of thinking about, we need to measure data everywhere, maybe focus on those areas where we know that there is higher degrees of uncertainty in our models, so we can systematically get these down. So yes, data is, I think, a big topic. It will always be, but as I said, with help of this digital urban climate twin, we will also be able to identify those areas where it's worthwhile to collect more.
And yeah, definitely data is a challenge. And maybe I would argue that Singapore actually, we are privileged to be developing this in Singapore because maybe we can talk about kind of trying to expand the DAC to other places. No, what would be the challenges to bring the DAC to other cities? Is that feasible? What can we expand beyond Singapore?
Yes, that's sort of the plan. The hope is, of course, that, we built this for the city of Singapore. The models are Singapore-specific. You can't take the same models and then use them in New York or somewhere else. But we can take the same approach, the same modeling tools, the same modeling approaches, perhaps others as well. There's also other models available for other cities. So the point is, if you want to bring this kind of system to another city, then you would have to replace the Singapore-specific models with the models of that city that you are interested in. But in particular, the applications that we put on top of it, they can of course be reused because they don't care whether this is a Singapore model or a Jakarta model or a Bangkok model or a New York model for that matter. Although that's also something that we need to keep in mind. Different cities have very unique circumstances and very different kind of problems. Here in Singapore, we have tropical climate, so humidity is a big issue. There's generally low wind speeds. So these are very different issues that we have here than people perhaps face in cities that are in different climate zones. So yes, the idea would be, of course, to bring this digital urban climate twin to other cities as well. But we will need data and also the models for that.
Well, I've seen that they've shown briefly the coffee break and all the eyes kind of open. We have a couple of more minutes. I don't know if there's any last question.
Hi, I want to know how does your simulation model process the data?
How does it process the data? Well, it depends on the model, really. So we have very different kinds of models. Typically, there's a pre-processing stage. So we have data about land use, land cover. We have meteorological data. We have all sorts of data sets, but they typically have to be pre-processed in such a way that they are digestible by the model. And that really depends on the model. In some cases, it's aggregating data to get it to a sort of a level of resolution that the model is working on. Fusing different data sets. It's basically there's a lot of these. A lot of what's going on is data pre-processing, making it digestible for the individual model, and then doing the reverse. What comes out of the model, post-processing that in order so that we can use it for further processing by the other models.
Go for the last one, yeah.
I'm really enjoying this. One of your big challenges, I'm guessing, must be interdependency with surrounding models or surrounding areas. So one example is, you could look at air pollution within Singapore, but if you're ignoring all the container ships outside of Singapore, you might get completely wrong predictions. So how do you tackle the surrounding impacts that you might not have within your model?
Well, generally the platform is open so that we can plug in new kind of models. Container ships is a good point. We have actually thought about this in the past as well, because air pollution does have some impact on the urban climate as well. We don't have this currently, but in principle we can add those. So the idea is that we start with something that works, and then once we realize where the weak points are, then you can add some of these models that are missing, including something like container ships, for instance.
So I think we need to wrap up. And no, it was great to hear all these questions and to see that we have sparked that interest. Feel free to approach us anytime after the session, to contact us through our website. If you want to know more, we will be very happy to share about the project. Thank you very much. Thank you.
Thank you.